Welcome to the video on interval and set notation. Interval and set notation. Let's start by imagining a number line, a line that represents all real numbers. And of course, numbers don't end, they go up past the billions and below the negative billions. And so we put the symbols infinity and negative infinity at the end of the number line, not because infinity and negative infinity are numbers, they're not, but because they represent that there's a never-ending list of numbers in both directions. Let's look at an example of a set. Consider all numbers from 3 to 7, represented here. This set would include numbers like 4, 7, pi, 6, or 3, just to name a few. In set notation, we could express that set this way. The braces at the end of the set are pronounced the set of all, or just the set, and this straight line here is pronounced such that. So this would be read, the set of all x such that x is between 3 and 7 inclusive. In interval notation, we would express the set this way. An interesting fact about interval notation is that it always has a comma in it, and that comma represents the word through. So this would be read, the closed interval from 3 to 7. The closed interval, by the way, is one that contains its numerical endpoints, and this one does. Before we go on to many more examples, I'd like to point out that this video is just describing a way that we can talk about pieces of the number line, or sections of the number line, also known as intervals. That we're not solving any math problems here. This is just a vocabulary and a description video. With that in mind, let's continue. Let's consider all numbers between 2 and 9, represented here. It's worth noting that the word between in math excludes, by its very definition, the endpoints. So when we say all numbers between 2 and 9, strangely, we're not including 2, nor are we including 9. This set would include numbers like 7, 2.66, 8.999, 2.001, and just to throw it in there, radical 51, which I believe is about 7 point something. Well, it contains all the numbers between 2 and 9, so how do we describe it? Well, we could call it the set of all x such that x is between 2 and 9. Or we could write it as an interval, again with the comma representing the word through, or to. I would pronounce this the open interval from 2 to 9. An open interval is one that does not contain its numerical endpoints. So when we write this interval, we're talking about all numbers 2 through 9, but not 2 nor 9. Let's consider all numbers that are both above 4 and also 6 or lower, represented here. The set would include 5, 6, 5.312, 4.001, and 4.0000001, just to name a few. In set notation, we could describe this as the set of all x such that x is 4 through 6, including 6. In interval notation, we could describe it this way. Again, I'd like to remind you that the comma represents the word through, so this could be read 4 through 6 or 4 to 6. But I would call it a half-open interval from 4 to 6, including 6. A half-open interval, which I guess could be also called a half-closed interval, but traditionally we don't. A half-open interval includes one of its two numerical endpoints. So, notice the parentheses at the 4 represents that 4 is not a member of this set. The bracket at the 6 represents that 6 is a member of this set. Let's consider all numbers -5 or higher, represented here. This would include numbers like -3, 0, -5 itself, 12, or 13 million and change. In set notation, we would simply write the set of all x such that x is greater than or equal to -5. Interval notation would be expressed this way: -5 through infinity. I would call it a closed interval from -5 to infinity because it includes its numerical endpoint, -5. Let's remember, infinity is not a number. This wouldn't be called a half-open interval. Let's consider all numbers higher than 4, represented here. This would include numbers like 6, 12, a billion, pi plus 7, and 4.00001, for example. We could write it as the set of all x such that x is greater than 4, or in interval notation, 4 through infinity, also known as the open interval from 4 to infinity because it does not include 4 as a member of this set. Let's consider all numbers 2 or lower. This would include 0, -1,000, 1, 2 itself, and negative radical 3, which is about -1.7. We could write this as the set of all x such that x is less than or equal to 2, or in interval notation we would write -infinity through 2, more specifically the closed interval from -infinity to 2, because it includes its numerical endpoint. It's worth noting here for a moment that interval notation is always written in left to right format. -infinity is to the left of 2, obviously, and therefore we write the -infinity first. It would be very strange, and in fact wrong, to call this the interval from 2 through -infinity. How about all real numbers? Every single number on the line. We could call that -infinity through infinity using interval notation. There are other ways to say all real numbers, but we'll leave it at that. Let's consider all numbers that are either 3 or lower or higher than 5, represented here. This set would include numbers like 3, -400, 1,000, 9, or 5.001. In set notation, we could simply write the set of all x such that x is less than or equal to 3, or x is greater than 5. Using interval notation, we have to use a union symbol, which is a mathematical way of representing the joining of two sets into one, as seen here. It looks like the letter U and was inspired probably by that, but it's not technically a U. I would pronounce this the union of the closed interval from -infinity to 3 and the open interval from 5 to infinity. Let's consider all numbers except 20. Literally every number that isn't 20, represented by this shading here. This includes 47,000, 0, -1,000,000, 20.0001, and 19.999. Every number that isn't 20. In set notation, we could simply use the not equal to symbol, the set of all x such that x isn't 20. Interval notation requires a union of two sets because these two sets are separated and don't overlap. I would pronounce it the union of the open interval from negative infinity to 20 and the open interval from 20 through infinity. It seems like a strange way of saying all numbers that aren't 20, but we do see this in interval notation, so it's something to be aware of. Let's consider the numbers 2, 4, and all the numbers between 5 and 10, represented here. This includes numbers like 5.001, 9.999, 7, 4 and 2, of course, themselves. In set notation, we'd simply write it out as you would imagine, the set of all x such that x is 2, or x is 4, or x is between 5 and 10. In interval notation, we use braces around the 2 and the 4. Braces around a set are just a way of representing a collection. Notice the comma between the 2 and the 4. That does not mean through, because braces do not make an interval or interval notation. So we're simply joining the numbers 2 and 4 themselves with the open interval from 5 through 10. I would pronounce it the union of the set consisting of 2 and 4 and the open interval from 5 to 10. And that concludes the lesson on interval notation.